Hello, my name is Derek Demeter, and I'm the Planetarium Director at Seminole State College. And for the next 400 seconds, I'm going to whisk you all away on a journey through the universe. Now, where should we begin our 40 billion light year journey? Well, probably someplace we all are quite familiar with, the planet Earth. About 7 billion human inhabitants on this planet, and it's the only place we know of for sure in this universe that has life cereal. No, life. Well, life cereal. But we're not too far, we're not too close, we're just right for life to exist on our planet. Now, Earth isn't the only place in our solar system. We have planets like Mercury, Venus, and Mars. Mars has the oldest surface in the entire solar system, about 4.6 billion years old. Venus has sulfuric acid clouds, and the hottest temperatures in the solar system, 900 degrees. And Mars has some of the largest geological features, like the largest mountain and the largest canyon. We also have the outer planets, Jupiter with its gigantic storm, the Great Red Spot, or the GRS, very creative. Saturn with its icy, rocky rings that make it the Lord of the Rings in our solar system. And Uranus and Neptune are like the Slurpees of the solar system, a mixture of ices, made up of methane and other gases. Then we got these guys, the dwarf planets. Pluto, Haumea, Makemake, Eris, Ceres. Yeah, these are all dwarf planets. Pluto, of course, being the one famous, and I'm not going to get into that debate about Pluto. But these are some really cool places in our solar system. And what about the little guys in our solar system? The asteroids, like the one on the top right. That's Cleopatra. It kind of looks like a dog bone. There's comets, Vesta, which is an asteroid we plan to visit. And there's even asteroids that have water, which are said to bring water to Earth a long, long time ago. But what are the very farthest reaches in our solar system? If you go about a light year away from our planet, you reach an area of tiny little pieces of ice that are just gently orbiting the star of our sun. That's the Oort cloud. And from this point on, we're going to leave our home, our solar system, and move outward through the universe. And trust me, we got a lot of grounds to cover. This is Fomalhaut b. This is a star that actually has other planets. We have discovered thousands of exoplanets in the universe. Some of these are larger than the planet Jupiter, and many of them, hundreds of them, are actually around the size or mass of the Earth. So maybe, just maybe, there might be life orbiting around another star. We actually can see where stars come from. These are little baby stars, aren't they cute? Aww. That's in the Orion Nebula. Each of those little squares has a star that's being compressed out of hydrogen and eventually going to release the amount of energy that's, well, what makes up a star. But stars come in all different shapes, and, well, not really shapes, but sizes and colors. And our sun, which is that little tiny red or yellow dot up there, we have Polaris, which is the North Star, Rigel, and even Antares. And there's even a star called v13 that's over 2.5 billion miles across. That's, if you replaced our sun, that would basically cover the entire solar system to Pluto. Now, stars about the size of our sun, well, when they run out of their fuel, they eventually form into carbon stars. And their outer layers, which are mostly hydrogen, expand outward, creating these planetary nebulas. So this is kind of like looking at our sun in about 5 billion years from now. So you got a little time to wait for that. But what about stars that are bigger than our sun? Well, they actually continue to fuse heavier and heavier and heavier elements in their cores. And eventually, when they reach the iron, they basically explode themselves as huge supernovas. This is Kepler's supernova. And all those colors you see there are all the ingredients making up that star. Now, we have carbon, oxygen, hydrogen, all the known elements of the periodic table. Well, that makes up us. Believe it or not, you, me, the computers, the microphone, everything we know of in our universe comes from star stuff, or stardust, not the coffee shop, but stardust, all the elements in our known universe come from stars. Pretty cool, huh? But what about even bigger stars? Some stars like Eta Carinae, when they blow up, they actually produce so much energy that, and since it's close enough, about 600 light years, will actually evaporate our entire ozone layer. That's another 100 million years or so we don't need to worry about that right now. But that's something that we need to concern ourselves if we want to maintain our life as a species. Now, this is our Milky Way. That's where we live. Now, this is an artistic rendition of our Milky Way because you can't see the Milky Way inside. But you see that little yellow arrow? That's home base. That's where we live. We live in the Orion Spur, kind of the Lake Mary Sanford of Central Florida. Kind of. if the Milky Way was Central Florida. This is the Andromeda Galaxy. This is our closest major galaxy to the planet. And actually, it's a picture I took. I just want to say that real quick. But that galaxy is actually on a collision course with our Milky Way in about 5 billion years from now. So the sun's going to die off. This galaxy is going to merge with us. A lot of crazy stuff's going to happen, right? Well, how do we know this? Well, we actually have found other galaxies that are colliding with each other. But here's the really crazy part. All the stars in those galaxies will never come in contact with one another, so the planets, there's enough space in between where these will become a mega galaxy. And then all of a sudden, it'll turn into separate galaxies, and it's just like a whole hodgepodge of galaxies. Speaking of which, that's a crap load of galaxies in that picture. In fact, that's the latest Hubble Deep Field image, containing over hundreds of billions of galaxies. Yeah. And each one of those galaxies may contain hundreds of billions of stars and trillions of planets. Whew. And I thought I was large. No, I'm not joking. But this is our structure of our universe. But doesn't it kind of look like something very familiar with our human brain? In fact, the neurons in our brain look very similar. And in fact, there are more neurons in your brain than there are stars in the universe. Now, think about this. Our human brain was able to conceive the idea of the universe. So we need to continue spreading the word and getting people interested in science so that way we can look up and realize that we're all connected to this great big place, the universe. So with that, thank you very much and have a great night.